Today we will discuss what is the physical state of water. We know we had discussed it today. Physical properties of water. Okay. So heading physical properties of water. That is first point. अगर हम लोग इसका वाटर का नेचर देखें नेचर तो वाटर कैसा होता है इसका कोई कलर होता है वाटर इज कलरफुल और कलरलेस वाटर इज कलरलेस ऑर्डरलेस टेस्टलेस क्लियर क्लियर तब होता है जब वाटर प्योर है प्योर स्टेट में वो क्या होता है ट्रांसपेरेंट होता है ठीक है so it is colorless odorless tasteless pure water is clear and it is transparent okay now अभी बोले थे कि वाटर का कुछ टेस्ट समझ में आता है तो वाटर का अगर कोई भी टेस्ट आ रहा है दैट इज फॉर द डिजॉल्व gases and solids dissolved gases and some solid impurities present in water make some taste to it okay dissolved gases and some impurities make it impurities make it taste. Second point, boiling point. Pure water boils at a suitable at fixed temperature. Okay? Pure water boils at fixed temperature. That is 100 degree Celsius. Okay. It boils at 100 degree Celsius. 100 degree Celsius में होता क्या है actually in this condition the pressure inside the water becomes equal to the atmospheric pressure. Okay. at this temperature, pressure inside the water becomes equal with the atmospheric pressure. Okay, अब ये बात याद रखना. सपोज मान लो कि ये मेरा सी है, सी लेवल, और ये मेरा है माउंटेन. यहाँ पर है एटमॉस्फेयर, क्लाउड. तो प्रेशर जो होता है एटमॉस्फेरिक प्रेशर, मतलब जो एयर है एटमॉस्फेयर का, वो कितना प्रेशर दे रहा है. ठीक है, तो अभी बताओ there is no one in the waiting room. I don't know who is facing problem. So the atmospheric pressure. Atmosphere will create more pressure at sea level compared to at the top of hill. Top of hill pressure is low at sea level, or below the sea level pressure is high. Okay, so here I told that at this temperature, that's mean at 100 degrees Celsius, temperature pressure inside the water becomes equal with the atmospheric pressure. So here atmospheric pressure is low, here atmospheric pressure is high. So water will boil at where? Faster or quicker compared to another one, where water will boil faster, at sea level or at mountain. Water will boil at mountain quicker than sea level. In sea level it boils at 100 degrees Celsius, but it mountain it boils nearly 70 degrees, 75 degrees Celsius. Okay, nearly 70 degrees Celsius. So we can say that pressure supporting power, ये तो था पहले से. pressure changes the boiling point of water. Okay, as the pressure decreases, ये pressure atmospheric pressure है. As the atmospheric pressure decreases, boiling point of water decreases. At the top of hill, it will boil quicker compared to the lower. Okay. Similarly, and vice versa. Okay, and vice versa. अगर प्रेशर हाई हो रहा है तो बॉइलिंग पॉइंट भी बढ़ रहा है. एनी डाउट?
No, sir.
Okay. Now, remember if some impurities is present in water, then boiling point of water will also increases. Boiling point of water will also increases as if this kind of impurity is present. Okay, why? Look here, like here at top of the hill atmospheric pressure is low, here atmospheric pressure is high. Since suppose this is container and it has pure water, suppose it has container and it has pure water plus some impurities. Okay, now think when we supply heat, it reaches 100 degrees Celsius. It's also reaching 100 degrees Celsius. But remember, here 100 degrees Celsius is totally captured by water. So it can boil. But here 100 degrees Celsius is divided into two parts. One part will be absorbed by the liquid water, another part will be absorbed by the impurities. So the temperature of liquid water is somehow less than 100 degrees Celsius. So to reach 100 degrees Celsius, we have to supply more amount of heat so that the liquid will absorb 100 degrees Celsius and starts to boil. So the overall boiling point will be increases. Okay, clear? Any doubt? अभी रिस्पॉन्स नहीं कर रहे हो कोई डाउट है या समझ में आ रहा है?
हाँ सर समझ में आ रहा है।
कीप राइटिंग, लिखते चलो। नोट डाउन हो गया यहाँ तक ना?
हाँ सर।
नोट डाउन हुआ है?
हाँ सर नोट डाउन हो गया।
ओके। थर्ड, freezing point. Freezing point of water. हमको पता है वाटर freeze to water freezes at 0 degree Celsius under normal pressure. Okay. Now what will happen if some impurities will present? If any impurities present, then freezing point will decrease. Similarly, like for boiling, when we supply heat, so heat is being divided into two parts. Similarly, for freezing, when we removed out heat from water, so due to some impurities, heat will be released from water and also from some impurities. So water having some higher temperature, we have to release more temperature. That's why freezing point will be decreased. Okay, like here, water releases temperature, impurities releases temperature. So both reaching the 0 degree Celsius. But on that time, water does not have 0 degree. It has sometimes something more. We need to remove more energy, more heat. Then water will equal to the 0 degree Celsius. Okay, this is freezing point. Next, density. Normally, density of water we assume is 1 gram per cc. 1 gram per cc. It is its maximum density. And for normal temperature, normal condition, we assume that water having the density 1 gram per when, but for ice having lesser density compared to water. Okay, जब जब वाटर आइस बन जाएगा तो वो सॉलिड फॉर्म में जा रहा है, बट आइस का डेंसिटी वाटर के रेस्पेक्ट में कम है, बहुत ही कम है. दैट्स व्हाई नोटिस किए होंगे वाटर से ऊपर आइस फ्लोट करता है. ठीक है, that is why ice floats over water. Okay, ice floats over water. This is 1 gram per cc for water. For ice 0.92. Okay. 0.90, that is 92% of water will converted to 100% of ice. That's why there is present some latent space inside the water molecules, ice molecules, some latent space, and due to that its density decreases. Okay. Relative density of ice होता है ये 0.90. That means 92% of water converted to 100% of ice, and due to that it having some vacant space. Okay. Next point, anomalous anomalous function of water. Anomalous expansion of water. Anomalous expansion of water means when we plot temperature versus density, then we can see as the increase of temperature, density first increases and then it again decreases. Okay, or we can say when we cooled when we cooled water, it first contracts its volume, so it contracts its volume, so density increases, and after a certain point, then it starts to expand and density decreases. Okay, that here. Suppose we plot a graph between density and temperature with a degree Celsius. So look at here, temperature increases this side. That means this side temperature decreases. Means we are cooling down. So as we cooled down, water molecules starts compressing. Start compressing means density increases. So density increases. After a certain point, when we further cool, the density decreases. Okay, this is known as anomalous expansion. Because after this certain point, water starts to expand. From here to here, water contracts. After this point, water expanding. It starts to expanding and continues to do so till the temperature reaches 0 degree Celsius. Okay. Now this temperature after which it starts to expand, that is 4 degrees Celsius. That means the density of water is maximum at 4 degrees Celsius. So in this point, one second. So when it cools, the temperature water contracts and density increases after certain value. That certain value is 4 degrees Celsius. After certain value, it starts to expanding and consequently density decreases. Maximum density of water maximum density of water That 4 degree Celsius. 4 degree Celsius maximum density. Maximum density. The value of maximum density is 1 gram per cc. So that 1 gram per cc reaches at 4 degree Celsius. Okay. Next, कंडक्शन। तो याद रखना है इसमें सिर्फ इतना ही कि वाटर जब प्योर हालत में है तो वो इलेक्ट्रिक कंडक्टर नहीं होता है। ठीक है। प्योर वाटर इज नॉन कंडक्टर, नॉन कंडक्टर ऑफ इलेक्ट्रिसिटी, बिकॉज इसमें उस टाइम पे कोई आयंस प्रोड्यूस नहीं होते। ठीक है। बिकॉज दिस इज बिकॉज इट डज नॉट फॉर्म एनी आयंस। याद रखना जब इलेक्ट्रिसिटी कंडक्टर होता है तो वो आयंस या इलेक्ट्रॉन्स के मूवमेंट से होता है। तो यहाँ पर इलेक्ट्रॉन नहीं तो यहाँ पर आयन भी फॉर्म नहीं होता है। ठीक है। लेकिन अगर हम लोग कुछ इम्प्योरिटीज डाल दे लाइक सॉल्ट गैसियस सब्सटेंस एनीथिंग देन इट बिकम्स इलेक्ट्रिकल कंडक्टर। ओके। प्योर वाटर कंडक्टर नहीं है, इम्प्योर वाटर कंडक्टर होता है। लिख लो उसको, इम्प्योर वाटर कंडक्ट इलेक्ट्रिसिटी। नेक्स्ट, latent heat। latent heat will latent heat will be discussed for every process. Look, we know water, liquid, water liquid to go to the water solid, and water solid again come to the water liquid. Liquid to solid. This process is known as this process is known as anybody present? Hello, anybody?
solidification.
Solidification or freezing? And water solid to liquid. This process is known as melting और फ्यूजन। नेक्स्ट क्या हो सकता है? वाटर liquid state can go to the water vapor. This process is known as vaporization. Vaporization. Okay. So latent heat is the heat which change only the state. Look here, water liquid to solid. But the molecular formula of water at liquid and solid both are same, H2O. So only state change. So the heat which is required to change only state of liquid, state of anything, okay, change state of substance, but not the temperature change is known as latent heat. Okay. Now latent heat for freezing, latent heat for fusion, latent heat for vaporization, latent heat for liquefaction. All will be calculated. So latent heat, the definition of latent heat is the amount of heat, the amount of heat is required to change the state only of any substance, but not the temperature, is known as latent heat. Now, if you will be asked what is latent heat of fusion, so we can say fusion means solid to liquid. So we can say amount of heat required to convert water solid to water liquid without changing its temperature is known as latent heat. Okay. Latent heat for vaporization means we are converting water from liquid to water vapor, but without changing its temperature. Like when water boils, so total water, the boiling point of total water remains constant, that is at 100 degrees Celsius, until total water convert into the vapor phase. Okay. Remember, latent heat of fusion is 336 joules per gram. That means 1 gram ice, we need 336 joule energy to convert 1 gram ice into 1 gram water at a fixed temperature. 1 gram ice to 1 gram water at a fixed temperature. Latent heat of vaporization, that is 2268 joules per gram. That means we need this amount of heat energy to convert 1 gram of liquid water to convert 1 gram of vapor. Okay. So latent heat means only the heat required to change the state but not the टेम्परेचर. मतलब जो टेम्परेचर में है उसी टेम्परेचर में वो फिक्स रहेगा बट अपना स्टेट चेंज करेगा. इधर इट विल बी सॉलिड टू लिक्विड और लिक्विड टू गैस और वाइस वर्सा. ओके. ओके. नेक्स्ट